This is our presentation on mutual information maximization on disentangled representations for differential morph detection. The majority of morph generation frameworks focus on altering the position of the facial landmarks. These frameworks mainly utilize three steps: correspondence, warping, and blending. Another trend of morph generation considers GANs to construct images that can be matched with the two source images. The face morphing algorithms can affect the face image in two broad aspects. First, they alter the position of the landmarks. On the other hand, they modify the appearance of the face image by either blending two source images or generating samples using generative models. Our proposed framework considers the disentangled representations for the landmark and the appearance of a face image. The proposed training setup ensures that the mutual information between representations of the real images from a subject is minimized. Let xi denote an appearance image and set li describe its landmarks. We find another face image x prime I from a different class corresponding to the closest set of landmarks L prime I. We use the thin plate spline to transfer the landmarks of the appearance face image to the landmarks of x prime I. Triplets of face images are used to train appearance and landmark networks. Appearance, landmark, and identity representations should satisfy three conditions. The appearance representation of the appearance and intermediate images should be similar. The landmark representation of the landmark and intermediate image should be similar. And for both non-manipulated images, the face representations should preserve sufficient classification information. We aim to maximize the mutual information between the real images from the same subject and minimize the mutual information between the samples in an imposter pair during the training, and make the decision during the test considering the distance between the representations of the pair of images in the embedding. Let ZAI and ZGI be the appearance and landmark representations for XI. We maximize the mutual information between the real images from the same subject in each embedding space using the functions TA and TG, where positive and negative sets include the genuine and imposter pairs respectively. Here we present the performance of our framework on three datasets. The top table do not consider the prior knowledge about which of the images in the pair fed to the recognition framework is a trusted image. On the other hand, the other table studies the effect of the trusted image being known to the detection framework. Here, for the baseline models, rather than comparing the representation of the trusted images and the images in question, the representation of the image in question is subtracted from the representation of the trusted image before feeding the difference to the SVM. We also consider an additional algorithm in which two dedicated instances of the framework are constructed for trusted images and images in question. In this algorithm, we only train the network dedicated to the images in question. In the left table, we study the performance of the networks trained on training portion of one morph dataset and tested on the other dataset. As presented in this table, the proposed framework provides high cross dataset performance. Finally, we present morphed samples from the considered datasets. For each dataset, the first and second faces are the gallery and probe bonafide images, and the third face is the morph image constructed from the first and fourth face images.